Hello guys, I want to answer some questions of differential calculus with you. In this case, I want us to go and look at this 7.2 of question 7, where they say determine the derivative of g of x. So I will answer different questions which requires us to determine the derivative of a function. Now we have to determine the derivative of g of x. So I'm answering this problem here. Sorry, I'm answering this problem here, 7.2. Now I want to derive the function g of x. So, but you guys, you need to be very careful. Don't rush into deriving the function. Sometimes, before you can even derive, there are certain things that you need to do. So, they want me to derive, but I still say g of x. When I write g of x, it means I have not yet started deriving. Once I start deriving, I will write g prime x. This means now I am deriving the function of g of x. But if I just write g of x, it means now I have not yet starting deriving. It's very important not to rush into deriving your function. So what you do, in this case I will say, you should not derive a function if your variable x is still the denominator. I'll just write d for the denominator. If you look at the variable which we are deriving with respect to, we are deriving with respect to x. And x, in this case, we have got 2x over x cubed. X is underneath. In this fraction, if you look at the fraction 2x over x cubed, x is the denominator. So you should not rush into deriving. When x is the denominator, try to remove your variable from being the denominator. How? I will say g of x equals to, I write this 5x squared minus, in this case I will say, let me say minus 2x to the exponent 1 minus 3. So here I have applied what we call law of exponent. The law of exponent. Okay, I want you guys to follow. If you have got something like this, look at the fraction that I'm writing now here. If you have got a to the power 3 over a to the power 2. You see, in this case, you have a fraction. You are actually dividing the exponent. In this case, the exponent is 3 and the other exponent is 2. In this case, you are dividing the exponent of the same base. Your same base in this case is a. We have got the same base a here. So law of exponents say, keep your base. If you are dividing, you should subtract your exponent. So you say 3, you subtract the exponent underneath, which is 2, which means your answer is a to the exponent 1, which is a. This is what we call law of exponent of division. If you are dividing the exponent of the same base, keep the base, subtract the exponent. So this is what I did. I had x over x cubed. So I kept my base x. You can see the base is x. The exponent here is 1. If there is nothing, it means the exponent is 1. So I set x to the exponent 1. I'm subtracting 3. So it becomes g of x is equals to 5x squared minus 2x to the exponent negative 2. Now, because you don't have x as the denominator, we can now start deriving the function. We say g prime of x equals to, let's derive 5x squared. When you derive, let me pick a different color a little bit here. When you derive, you go to the exponent of your variable. Your variable in this case is x. So you take your exponent of the variable, which is 2, you multiply with the coefficient of your variable, the number before your variable. Remember, your variable, I said it's x. Your exponent is 2. Your variable is x. So you say 2 times 5. You get 10. You get 10. So you say 10. You keep your variable x. The last step when you derive, you have to go back to the exponent and subtract it by 1. So your exponent was 2. Remember, we are deriving 5x squared. So your exponent is 2. When you subtract 2 by 1, you have got 1. Normally, we don't write exponent 1. Okay, now let's go to derive this minus 2x squared. Now we are deriving this part, minus 2x to the exponent negative 2. I said always go to the exponent of your variable. What is your variable? X. What is your exponent? Negative 2. Now take the exponent of your variable. In this case, it's negative 2. Multiply it with a number before the variable, the number before x. The number before x is negative 2. It's very, very important to take a number with its sign. It's not just 2, it's negative 2. So you say the exponent negative 2 times the number before x, which is negative 2. So negative 2 times negative 2 is positive 4. So you say plus 4. You keep your variable x. Keep your variable x. I kept my variable x. Last step of deriving, go back to your exponent. In this case, your exponent is negative 2. Subtract your exponent by 1. Negative 2 minus 1, it's minus 3. So you have derived your g of x. The derivative of g of x is 10x. You can even write it like this. You can say g prime x is 10x. X to the exponent 1 is just x. 10x plus 4 all over x cubed. You guys, you have to know that x to the exponent negative 3 can be written, we say we normally write it in terms of a positive exponent. X to the exponent negative 3 can be written as 1 over x to the exponent 3. Yes, we are going through the ideas of deriving the function. Let's look at it again. It's very important. Let's summarize what we were talking about. We are having, let me find the eraser. Let me find eraser. We are deriving 7.2. We are determining the derivative of a function. What are we deriving? We are deriving 5x squared minus 2x over x cubed, which is what has been given here on this question. We are deriving this function here. G of x equals to 5x squared minus 2x over x cubed. So my tip, my first advice, you see x here is underneath, is the denominator. You have a fraction, 2x over x cubed. Your x is still the denominator. Don't rush into deriving. You know that you must do what? You must remove x from being denominator. You must remove your x from being denominator. And what was important doing this, we applied law of exponent. It's very important to see that x divided by x cubed is x to the exponent 1 minus 3. How come? The base is the same. This is the same as x to the exponent 1 divided by x to the exponent 3. So your base is x. The base is the same. You keep your base. What do you do to the exponent? You subtract them. You say 1 minus 3. So you have x to the exponent negative 2. This is how you are going to remove x. Now, let's write. What are you going to do? I'm writing it here. You are going to say g of x. It means I have not yet started deriving because x is still the denominator. Don't rush into deriving. Sometimes before you derive, there are certain things that you need to do. Now you say g of x equals to 5x squared minus 2. I told you that x over x cubed, it's x to the exponent negative 2. Now, because you no longer have x as the denominator, you are now ready to derive your function. You say g prime of x equals to, you are now ready. When you derive, watch out for the exponent of the variable. What is the exponent of the variable? In this case is 2. What is your variable? Your variable is x. So you take the exponent of a variable which is 2, you multiply it with the coefficient of a variable, coefficient of x. The number before x is 5. So it's 10. So you're going to say 10. You keep your variable is x, you keep it. What do? You go back to the exponent, which is, your exponent is 2. Remember, it was x squared. You go back to that exponent 2, you subtract it by 1. So 2 minus 1, it's 1. I'm just writing it somehow because normally we don't write it. And then now you say, you come to this other function here. You now come to this one, minus 2x to the exponent negative 2. You have to derive this one. What do? You go to the exponent of a variable, which is negative 2. You multiply it with a number before your variable. Your variable in this case is still x. Number before x is negative 2. So you say negative 2 times negative 2, it's how much? It's positive 4. So you say plus 4. You keep your variable. Your variable, I'm keeping it. I'm writing it here. It's what? It's x. I'm almost done. But don't forget to go back to the exponent and subtract it by 1. Your exponent is negative 2. You subtract it by 1. So when you subtract negative 2 by 1, it's negative 3. Sorry. It becomes 4x to the exponent negative 3. So you can write your final answer like this. You can say it's 10x plus 4 over x cubed. The advice here, you've finished deriving the function. My advice here that you have to remember, you don't have to start deriving as long as your variable is the denominator. As long as x is still underneath, don't start deriving. Let me show you in the simpler context. Let me show you in a simpler way. Let me say you have, I want to make it simpler. Let's say you have, we are teaching maths, guys. We are doing maths. Let's say you have f of x is equals to 2 over x cubed. And you want to derive this function 2 over x cubed. My advice, don't start deriving as long as this guy x is underneath your fraction. As long as it's the denominator, you need to bring x on top. In this case, you say f of x. Your first step in this case, you say 2 x to the exponent 3. It's more like it's coming on top. In this case, it becomes x to the exponent negative 3. You see, my x is no longer underneath. It's no longer the denominator. My x is no longer the denominator. Sorry, what's happening? Yes, it's 2x to the exponent negative 3. Now, because x is no longer the denominator, you can now derive. You say f prime x, which implies you are deriving now. What you do when you derive, you go to the exponent of a variable. In this case, it's negative 3. Is the exponent of the variable. What is my variable? My variable, guys, is x. My variable is x. So I go to the exponent of the variable, negative 3. I multiply it by 2. Negative 3 by 2, it's 6. Keep the variable, keep this guy, x, keep the variable. What do you do to, lastly, you are almost done. Remember to subtract your exponent by 1. So this is negative 3. You subtract it by 1, you have negative 4. So f prime x equals to 6x to the exponent negative 4. My tip: do not start deriving if x is still the denominator. Let me give you one more last example which relate to this one. Because I love you so much, guys, I want you to pass. So I can even write it here, right here. Let's say you have f of x equals to x cube over 2. You can come in x cube over 2